In this video, I'm going to go over factoring, which really you would need synthetic division to probably do. Um, Here's a cubic because the largest exponent is a 3, and um, some cubics are easier to factor. Like in another video, we did something like x to the third minus 125, and we did x minus 5, and another factor was x squared plus, not 25, but 5x plus 25. So that's in another video. So that's a pretty easy cubic to do. When it's more complicated like this one, really I'm pretty much left to synthetic division, or ordinarily we'd probably use a graphing calculator. But let's show you how to do synthetic division. So what I do, first of all, this is written in descending order. The first exponent is a 3, then exponent of 2, then exponent of 1, and then exponent of 0. So it's in descending order. So you need to do that if it's not in descending order. Put it in descending order. All right, the next thing to do is to look at the last term, the last coefficient, and the first coefficient. Okay, and find the factors. So the first factors I start with is the last coefficient, the negative 15, and what can I divide it by? Okay, so I'm going to write what's called potential roots. All right, even though this is a section on factoring, um, synthetic division actually find roots, and then from roots we can create factors if we need to. Okay, so the factors of a negative 15, I can divide it by a positive 1 or a negative 1 without a remainder. Also, I can divide negative 15 by a positive or negative 3, a positive negative 5, or a positive negative 15. So those are all the factors of negative 15. Now, I also need to do the factors of the first coefficient, which is a 1. Now that's actually very easy, and this is the more a really simple um, cubic function we can factor. Um, the 1, what I can divide into 1 is a plus or minus 1. So what I'm supposed to do is write the negative plus or minus negative 1 from the negative 15 and put a plus or minus 1 underneath that, a plus or minus 1 underneath the negative plus or minus 3, plus or minus 1 underneath the plus or minus negative 5, plus or minus 1 underneath the plus or minus 15. Well, that's well, that just doesn't add anything, because when you take a 1 divided by 1, I'm getting a plus or minus 1. So when that happens, I can just ignore all these denominators here. So really, these are the factors, potential roots that I have. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. All right, let's go on into the division. Okay, what I do now is take all my coefficients of my terms. In front of the x to the third, that's a positive 1. Try to 1 for that. In front of x squared, I see a subtract sign, so that coefficient is a negative 1. In front of the x is a negative 17. And of course the last is a negative 15. Alright, now instead of doing this like we did with long division in elementary school or so forth, okay, I do something that really close to that. I draw it like this. Okay, this is synthetic division. Synthetic division. Alright, so I pick one of my potential roots, and I usually just start with the smallest one. I see a positive 1 as our potential root. I put a positive 1 on the outside. Okay, so what I do now, and this is always the first step, is always whatever our first number inside there is a positive 1, I just drop that down. I don't make any changes to it. Whatever it happens to be, I just drop it down. Okay, so now I take that brown one, there's an arrow, multiply it by that pink one. 1 times 1 is 1. Let me switch back to black. So I put a 1 under here. Okay, and then I find out what negative 1 plus 1 is. Of course, that's 0. I drop a 0 down. Now I go back to this divisor out there, which is a positive 1. Multiply that by a 0. I get a 0 right there. Put that underneath negative 17. I drop that, combine those two numbers. I get a negative 17. And then go back to this positive 1 on the outside. Multiply it by that negative 17. I get a negative 17. And what I'm hoping for is this last spot right here to be a 0. And you can see that's not going to be a 0. That's a negative 32. So that means this number that we tried on the outside is not a root. Okay, so I'm going to erase that. Erase all this I've done earlier, except my coefficients I had. I'm going to try my next potential root, negative 1. And this will go faster as you go, get more practice. Alright, okay, I'm going to drop my first number down. I'm going to multiply the negative 1 times this positive 1, I get a negative 1. I combine here, this time I get a negative 2. Okay, multiply that negative 1 on the outside times that negative 2, I get a positive 2. Okay, and this one I can see is going to work really well because negative 17 plus 2, that's a negative 15. And then so I take my negative 1 out here, times that negative 15, negative times negative is positive. I get a 15, and this is what I want to see, is 0 right there. Okay, so that means negative 1 is an actual root. So negative 1 is one of my roots. Okay, now because this is a cubic, my biggest exponent is 3. The most different roots I can have is 3. I can't have 4 or 5 of them. I can only have 3. Okay, so I'm looking for maybe 2 more. All right, now what I can do next, I can do a couple different ways. Okay, I can actually go from here and say, well, all right, the 1, the negative 2, the negative 15, that really stands for 1x squared minus 2x minus 15. Okay, and I can actually factor that. Now it's x squared because that's 2, because I did one synthetic division. I started with a 3 up here. Now I go down 1. Now I have a 2. Alright, so can I factor that? Yeah, we can factor that. Okay, x and x. Alright, negative 15, I can multiply a negative 5 times a positive 3 to make a negative 15. And when I add a negative 5 plus 3, I get a negative 2. So negative 15 is my last term, negative 2 is my middle term. So I'm going to use a negative 5 and a positive 3 as my factors. And my solutions, or my roots, are x equal positive 5, x equal negative 3. So over here underneath my actual roots, I already had a negative 1. I'm going to put a positive 5. I'm going to put a negative 3. So there's my roots. Okay. And depending what your problem is, and most times when you're doing this kind of problem, you're probably finding roots, not factors. But we can change these to factors. The negative 1 means one of our factors is x plus 1. The 5 as a root, it means our other factor is x minus 5. And the actual root of negative 3 means our other root is x plus 3. Okay, so there's my 3 factors. Okay. Now, there was another way to actually do the synthetic division, so let me move this out of the way. We can actually keep going with synthetic division again. So what I would do is I draw another line. Okay, I'm going to pick another term. Okay, so plus 3. Okay, we might think plus 3 is a root, and of course we actually know it's a negative 3, but just for terms of trying some, we'll try positive 3. Alright, we drop our first term, 1. That 3 times that 1 is a 3. Negative 2 plus that 3 is a 1. Okay, that 3 on the outside times that 1 is a positive 3. And alright, we get a negative 12. That's not a 0. So, yeah, we're showing that positive 3 is not a root. Okay, we knew that earlier. But let's try negative 3 just to show that this process does work. Drop that first number. Alright. The negative 3 times a 1 is a negative 3. Negative 2 plus a negative 3 is a negative 5. Okay, and then this negative 3 on the outside times that negative 5, that's a positive 15. And we got our 0. So we know that's another root. Okay. And we can actually do it one more time. Draw a line again. Let's see. We know our answer is 5. Let's just try 5. Alright. Drop the 1. The 5, that green 5 times the green 1 is a 5. Get a 0. And so there's our third root. And once we're down just to one number, we're done synthetic division. All right, so that's a way to do it. Let's try another one. All right, so this time it's a cubic, but we start with a negative. So let's start with our potential roots. All right, 16, potential. 16 I can divide by plus or minus 1, a plus or minus 2, a plus or minus 4, a plus or minus 8, or a plus or minus 16. Okay, and our first coefficient is a negative 1. All right, so when I divide by plus or minus 1, you know, that's just something we don't need to do because we don't change any of those potential roots at all. So I'm going to erase that. We don't need that. Okay, eventually we'll have a problem where we do have something other than 1 in front. All right, so write our coefficients. Negative 1 in front of x to the third, a negative 4 in front of x squared, a positive 4 in front of x, and a positive 16. All right. Okay, let's start with a positive 1, see if that works. Okay, drop the first one down, negative 1. 1 times a negative 1, that's a negative 1. I get a negative 5. The 1 on the outside times a negative 5 is a negative 5. And really I can stop here. I see it's not going to work. Okay, so that didn't work. Alright, so erase all that stuff. So, alright, positive 1 didn't work. Let's try negative 1. Negative 1 times negative 1 is a positive 1. Negative 4 plus 1 is a negative 3. Negative 1 times a negative 3 is a positive 3. You get a 7. Negative 7. That does not work either. Okay, so positive 1 and negative 1 don't work. Alright, so let's try 2. 2 times negative 1 is a negative 2. These two have negative 6. Negative 12. Okay, 4 plus a negative 12 is negative 8. Times 2 is a negative 16. Alright, good deal. So 2 is an actual roots. So actual. And there are other names we can call these solutions or x-intercepts or zeros. So positive 2 is one of our roots. Alright, okay, now again we can go and say we can change this. Okay, we can change to, we can actually put the x squared and x in there and factor it. Alright, we can do that. It would actually be easier to factor if we actually change the signs. And we can do that because we can set this equal to 0 and just divide both sides by negative 1. Okay, and we get an x squared and a positive 6x and a positive 8 because you divide all those terms by negative 1. And then from here it's pretty easy to factor. You know, 4 times 2 is 8. 4 plus 2 is 6. So we see our actual answers are negative 4, negative 2. Okay, so we can do that, negative 4 and negative 2. Alright, but let's say we don't like to use that, we don't like that negative there, or you know, we just like to practice our synthetic division. Let's keep going. Let's try synthetic division again. Alright, let's try the negative 2, since we know that's a solution. Alright, we got a negative 1. Negative 2 times negative 1 is a positive 2. Negative 6 plus 2 is a negative 4. A negative 2 times negative 4, that's a positive 8. Okay, here's another actual root. And let's try the positive 4. Okay, negative. Try it again. Positive 4, negative 1. 4 times a negative 1. Ooh, that's a negative 4. It didn't quite work there. Okay, so let's try the negative 4. Alright, negative 1 and negative 4 times negative 1. That's a positive 4. It's 0. Alright, so there's our 3 roots. Okay, so how we make factors out of this? Okay, so we just say x. Instead of a plus 2, we say a minus 2. Alright, instead of a minus 4, we say x plus 4. And instead of that minus 2, we're going to say x plus 2. Alright, now, there's one little complicating factor in this, and that's this. At the very beginning of our original problem, there is a negative 1 right there. Okay? And when I actually multiply these three terms, let's go ahead and multiply them. Let's multiply x minus 2 times x plus 4. That would be x squared plus 4x minus 2x minus 8, which becomes x squared plus 2x minus 8. And multiply that by the x plus 2 at the end. We would have x to the third plus 2x squared minus 8x. I'm just multiplying all three terms in that first parenthesis by the x in the second one, and then plus 2x squared plus 4x, and then minus 16. And add this all up, I get x to the third plus 4x squared, a negative 8x plus 4x, that's a negative 4x minus 16. Alright, so that's really the same as the first problem, except all the signs are opposite. So what I have to do to do the factors, I have to slide in a negative 1. A negative 1 times those three factors will equal what we started with. Okay, so just be careful when you start with a negative coefficient. One of your factors is going to be negative 1. All right, let's try 1. It's a little longer. I know these seem like going to be a lot of work, but you practice it a few times. It's going to be pretty good. All right, let's go a little quicker. 30 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 5 plus or minus 6 plus or minus 10 plus or minus 15 plus or minus 30. Alright, this is a quartic because the largest exponent's 4. It is in descending order. Okay, our first term is in 1, so our potential roots are all good. So here's our potential roots. Okay, and we're looking for 4 answers at most. So write our coefficients: 1, 3, negative 15, negative 19, and 30. Let's try a positive 1. 1, that's 1 times 1 is a 1. Get a 4, 4 times 1 is 4. Negative 11, 1 times negative 11. Okay, this becomes a negative 30. Times 1, that's a negative 30. Okay, very good. Got a 0. We got a root. It's not a factor, it's a root. Alright, positive 1. Okay, now we start with x to the fourth. Now, if I try that little technique like I did with the cubics, I would go down 1 to be x to the third. So this 1 right there means my remainder is 1x to the third, then a 4x squared, then a minus 11x, then a minus 30. That's a cubic, and that's kind of a hard one to do. So I don't think we need to stop. We need to keep going with systematic division. Okay. All right, let's try again. Let's keep going. All right, now the next answer could also still be a positive 1. Okay, you could have the same root more than once, but I actually set it up so I have different roots. So I'm going to try negative 1. Okay, let's see what happens. All right, a 1. Negative 1 times 1 is a negative 1. 4 minus 1 is a 3. That's a negative 3. Negative 14. Okay, that's not going to work. All right. So positive 1 works, negative 1 doesn't. So let's go to 2. Okay. All right, drop the 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. That's a 1. All right, 2 times 1, that doesn't work. Okay, let's try negative 2. 1. Negative 2 times 1 is a negative 2. 4 minus 2 is a 2. 2 times a negative 2. Negative 2 times 2 is a negative 4. That becomes a negative 15 times a negative 2. There's a 30. Okay. So we get what we want, a 0 there. Okay, so we got another actual root. Okay. Again, we could use, keep going with synthetic division, but let's try just factoring. Okay. So that's a positive x squared. That's good. Much easier to factor that way. X, negative 15. I'm thinking about a negative 5 times a positive 3 or a positive 5 times a negative 3. Either of those multiply to make a negative 15, but these two, the positive 5 and the negative 3, that adds up to our middle term 2. So we're going to have an x plus a 5, just match that. That's a positive 5, that's a negative 3. Okay, there's our two factors. We can say our roots are negative 5 and positive 3. Again, when you're doing these kind of problems, most likely you're finding roots and not factors, but very easy to change roots to factors. So our factors, instead of positive 1, we're going to say x minus 1. Instead of negative 2, we're going to say x plus 2. A negative 5, we're going to say x plus 5, just change the signs. And a 3, x minus 3. Okay? It's a positive, so I don't need to add a negative 1 there. Those are my factors. All right? Okay, this one, back to a cubic, and again we have a negative in front. But you see we're going from 3 to 1. Now it's in descending order, but there's a gap. There's no x squared term in here. Okay? Synthetic division will deal just fine with that. Alright, let's start out easy. Potential roots. Again, you can call them zeros, x-intercepts. Graphically, this is really good to help you graph. You can call it solutions. Alright, all those mean the same thing. Alright, a negative 12, I can divide it by a plus or minus 1, a plus or minus 2, a plus or minus 3, a plus or minus 4, plus or minus 6, a plus or minus 12. Okay, so here we go. Let's see, a negative 1, a 13, and oh, I'm going too quick. Okay, alright, this is what you have to watch out for, what I just did. Okay, there's a negative 1 for the x to the third, but there's nothing for x squared. So I'm going to put a 0 there for the x squared term, because there literally is no, there's 0 x squareds there. Alright, then I'll put a 13 for the x and the negative 12. So you gotta, doing synthetic division, you have to fill in missing gaps. Alright, let's try the positive 1. Okay, and then negative 1. Okay, 13 minus 1 is a 12. Okay, good. Right the first time we got something that works. Okay, so actual. So this process is a little bit of trial and error. Okay, all right, so we could do this. Okay, factoring these kind of things is not as easy, and I don't see, because you have a negative x squared, you can say a negative x and a positive x. And what are you going to do with 12? Probably 4 and a 3. And let's see, that's a positive 12, so either both positive or both negative. Let me try both positive. Okay, so we'd have a 4x there, and we have a negative 3x there. Okay, that's really close. So all it means is really my signs are backwards, which means I don't need to change those signs. I need to change where the 4 and the 3 are at. So let's try the 3 here and 4 there. And so I get a positive 3x there, and I get a negative 4x there. Okay, and that adds, these two add up to my negative x. So I have my other factors. Okay, so if I set negative x plus 3 equals 0, I would subtract 3. I'm trying to find my roots now and divide by negative 1. And so positive 3 is another root. Alright, this one is easy. X plus 4 equals 0. I got a negative 4. So there's my 3 roots. Okay? Alright, let's say you didn't want to go through all that factoring with a polynomial. Okay? In this case, I think probably just synthetic division be, quicker. Okay, so let's see. Alright, let's check our answer. Our next answer is 3. Let's try 3. Negative 1, 3 times negative 1, that's a negative 3. These add up to negative 4. 3 times the negative 4, that's a negative 12. Yep, 3 is one of our actual roots. And let's try our negative 4. Okay, drop down to negative 1. Negative 4 times negative 1 is a 4, 0. Okay, so here are our 3 actual roots, 1, 3, negative 4 factors. Okay, so we got a plus 1, so I'm going to write x minus 1. There's a positive 3, so I'm going to write x minus 3. And a negative 4, I'm going to write x plus 4. Okay, now what do we do? I believe, I erased it unfortunately, I either had a negative x plus 3 or that's what I had. And when I factored it, a negative x plus 3. Okay, if you look at the x minus 3 right here, if I multiply that, and that x minus 3 right there, if I multiply that by a negative 1, I get this, which I had in the parentheses earlier. Okay, so that negative 1 is still there. So let's go ahead and go back to the original problem. That's a negative in front. So let's add that negative 1 as our factor. So when we multiply it out, it'll match the signs and everything. Alright. I think I have one more left. Okay, yes. So this is a problem I had. Actually, there are actual problems where you have something other than 1 to start with. So that's not 1, but this is 2 this time. Okay. Alright, so we're going to start the same way. I'm going to start the last number first, and that's always going to be your numerator. Okay, so 6. That's why we start with the last number, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Alright, what are the factors of that 2? Plus or minus 1, plus or minus 2. So what I'm really supposed to do, plus or minus 1, plus or minus 2, whoops, my fault, plus or minus 1, all the way through. And then write that first list again. And this time divide all these by plus or minus 2. Which says, oh, I got twice as many potential roots as I did before. Well, not really. You have more, but not twice as many. First of all, this, when divided by plus or minus 1, that's not going to change. So I'm going to erase all these. Alright, now what's going to happen when I divide a plus or minus 1 by a plus or minus 2? I could either get a plus or minus 1/2. So that is another potential root. Alright, this next one, plus or minus 2 over plus or minus 2, I just get plus or minus 1. Okay, so that doesn't give me any more potential roots because I already have a plus or minus 1 in my list. Alright, this one will give us another potential root, plus or minus 3 over 2. And this last one, plus or minus 6 over 2, well, that's just plus or minus 3, which we already have. So our list is a little longer than it would be otherwise. Alright, but we do it still the same way. Alright, so let's start out. It's only a cubic, only 3 answers. So I'm going to start with a 2, then a 3, and then negative 11, then negative 6. Make sure you get your signs right, otherwise it'll be endlessly frustrating because you don't have your signs copied down exactly the same. Alright, let's try our 1. Okay, so that's a 2 this time. Okay, the 1 times the 2 is a 2. 3 plus 2 is 5. 1 times 5 is 5. Negative 11 plus 5, that's a negative 6 times 1. Okay, everything's good except the signs. I got a negative 12 there instead of a 0. So maybe the negative one's going to work. Let's try that. Okay, drop down to 2. Negative 1 times 2. 3 minus 2, that's a 1 this time. Negative 1 times 1, that's a negative 1. That's a negative 12. Okay, no, that doesn't work. Okay, don't get a 0. Alright, so let's try 2. 2 times 2 is 4. 3 plus 4 is 7. 2 times 7 is 14. Negative 11 plus 14 is a 3. 2 times 3 is 6. Okay, there we go. Alright, so one of our actual roots is at 2. Okay, so we start with x cubed. So this 2 really stands for 2x squared. Just go down 1 from 3 to 2. Then there's a 7x, and there's a 3. Alright, we can factor it. Okay, and this is a little more guess and check because, again, you're starting with something other than 1. So by no 2x squared, I can only use a 2x and an x. And 3 is a prime number, just like 2. So only thing I multiply by 3 is a 1 times a 3. Now again, I can think about a negative 1 times a negative 3, but I know that's not going to work because I have a positive inside. So I kind of use a combination of guess and check, but I know my rules. So I know these don't work. So I got a 1 and a 3. Now, since our 2x and x are not the same, where I put the 1 and 3 make a difference. And so I just think it out. If I put a 1 right there and a 3 right there, I just think it out. I drew a little arrow there like I'm thinking. Okay, I want to put maybe a 1 there and a 3 there. What would happen? Well, that 3 will multiply by the 2x. That's the outside in FOIL. Okay, that'd be the outside. The 3 times the 2x, that would give us 6x. And the 1 right here times x, that'll be my inside. They'll add up to 7x. So, even though I'm writing stuff down, I'm showing you what I'm thinking as I go. Okay, this can actually be done pretty easy. Let's put a 3 there and a 1 there. Both positive. Double check. Okay, we know 2x times x, that's 2x squared. The 2x times the 3, that's a 6x. The 1 times x, and then the 1 times the 3. And we get 2x squared plus 7x plus 12. So that's our factors. Okay. Alright. What are the roots, actual roots? Okay. I would set 2x plus 1 equals 0. Of course, I'd just do that mentally. I'd change the 1 to negative 1, and I'd put a 2 underneath there to match that 2 there. So my another actual root is negative 1/2. And of course, this one, x plus 3 equals 0, negative 3. Okay. Alright. Well, let's say we didn't want to go through all that, because I really did want to show you this synthetic division, how it really works. It still works with fractions. Okay, so we can kind of cheat a little bit. We see that negative 2 is not going to work. We see that positive 3 is not going to work. Let's go ahead and use negative 3. Okay, 2, negative 3 times 2 is negative 6. That's a 1. Okay, negative 3 times 1 is a negative 3. That's our 0. And just because of our answers we see over here, we know that the plus or minus 6 is not going to work. So let's go with that negative 1/2. Show you what happens. Okay, just put a negative 1/2 out there. Just drop first number like you're talking about. We're going to have to do negative 1/2 times 2. That just means a half of 2, which is 1, but then we'll make it negative. Okay, so negative 1/2 times 2, that's a negative 1. So I just put a negative 1 there. Okay, it works just fine. So there are my 3 actual roots, my factors. X minus 2, x, change that to a plus 1/2, and then x plus 3. Double check our original problem. It starts with a positive. Okay, so I don't add a little negative 1, that's it. And there's my factors, and there's my roots. And that's it.